Now this is very similar to what we did last lesson. The only difference is we've actually made this a little more complicated now. And rather than just having x squared, we've also got this rational function in here. We could extend this to cubic graphs or quartic graphs as well. Find the coordinates of the stationary point or points, so turning points, maximums and minimums, points of extrema. And then say with reasoning if these are minimums or maximums. So the first thing we've got to know is how do we find those stationary points? And we know the slope is 0, so we need to differentiate this and set it equal to 0. So I differentiated this, brought the negative 1 to the front, and then decrease the power by 1, and differential of x squared is 2x. And I can rewrite it like that. And that's actually going to be useful because we actually want to set this equal to 0 and solve. So write that statement out and explain to the examiner exactly what you're doing. Maximum and minimums occur at dy by dx equals 0. And then take that equation and set it equal to 0. Now, when I've got negative terms, what I like to do is bring one to the other side and make it into a positive term. And I also don't like fractions, so I can multiply to the other side now to get rid of that fraction as well. So 2x cubed equals 54. Divide both sides by 2. And there's only one solution to x cubed. It's just going to be 3. Negative 3 doesn't work. Negative 3 cubed would be negative 27. Now, same idea as what we were doing the other day. Once we've found that one value, we can substitute back into the original equation to find out what the y value would be for this point. So if we plug 3 into the formula, we get 3 squared plus 54 over 3, which would give us 27. So we know we have a turning point now at 327. What we don't know is what type of turning point or stationary point is it? Is it a maximum or is it a minimum? So what we have to do is we have to go back to that first differential, and then we have to differentiate this. So differential of 2x would be 2. Differentiate this, bring the negative 2 to the front so it becomes positive 2, times by 54, 108, and then decrease the power, so x to the negative 3. And that's actually what I did on this next line here. Now we want to find out what this value is for our x value, so we need to plug 3 into this formula. So 3 cubed is 27, 108 divided by 27 is 4, and 2 plus 4 is 6. The important part about 6 is that it's greater than 0. Anything that is greater than 0 means that it is a minimum at the point we are given. So all these questions are going to be very similar now. What's going to be slightly different is our second derivatives and first derivatives might be slightly more complicated to work out, and also solving them equal to 0 might be slightly more complicated than what they were in the previous lesson. But that's the basic idea that we're going to use for these questions.